So now starting with number 8, let's see. We've got, oh, this is a quadratic. Okay, so I need to use the quadratic formula for this. How does it go? Negative b, oops, there it goes. Negative b plus or minus square root of b squared minus 4ac all over 2a. So that's what I need to plug in. The show your work for this part is you just identify this as a, identify this as b. That's a negative 3 that is b, and identify this as positive 4 as c. So that's the show your work for the quadratic formulas. Now I plug it into this equation. So x equals negative plus or minus the square root of b squared minus 4 times a times c, all this over 2a. I like to put these parentheses in to get my formula down, then plug the numbers in. Okay, negative b, so that's negative 3, right? So negative 3, yep, that's right. I need to square negative 3. Remember that negative 3 squared is positive 9. Minus 4a, which is negative 2. C, which is positive 4, all over 2a, which is negative 2. And I don't have to actually solve this. I just need to look in the list and see if I can find something. Negative negative is positive 3, so it can't be that guy. Can't be that guy. One of these two. Should have 9 underneath there. Oh, this is the wrong stuff over here. It can't be that because I'm adding. I'm supposed to multiply these things. So it must be this one. And I think that matches up pretty well with my formula there. That's perfect. Okay, number 9. Again, going through PEMDAS to remind you. I invert by going backwards through PEMDAS. Two things are happening to x. What are the two things? I've got multiplication by 2. That's there. I've got a 10 to the x. That's an exponent kind of thing. So undo multiplication first. Undo multiplication of 2 by division by 2. On the left-hand side, the 2's cancel out, leaving me just 10 to the x. On the right-hand side, I get 10. Now I undo 10 to the with, do you remember what this is? It's the inverse of 10 to the, which, oops, there we go, is log. So these two invert each other. I need to take the common log, log base 10 of both sides. So I would take the log of 10 to the x equals log of 10. Log and 10 to the just cancel each other out, leaving just the x. So I should end up with x equals. And on the calculator, I just type in log of 10. That's an easy one to do as well. 10. Log is just a unary function, so I'll get 1 out of that. X equals 1, which is in my list, actually. So that's good. You could just look at this. You know, in the general case, you could look at this part right here and say, well, what is x if I hit 10 to the something and I just have nothing over here? That must be a 1. It's above that as the exponent. But in general, it's easier to rely on the log function to tell you what the answer should be. Ooh, this next one looks interesting. E to the x to the 2. Okay. This one is all exponents. So I can't really use PEMDAS to plan this out. They're both exponent kind of things. So remember that you're supposed to go from the ground up. You're supposed to undo the e first, and then you have to undo that squaring. That has to be last. So how do you undo e to the something? Again, on the calculator, I remember that there's natural log and the natural antilog, which is e to the x. So that's what I need to do for both sides. Take the natural log. So we do ln of e to the x to the 2. On the right-hand side, that's just a number. Always on one side, you're doing just the calculator work. On the other side, you're unwrapping, you're unraveling what's happening to x. ln and e cancel each other out. Everything that's the exponent just comes right down. It just pops right down there. On the right-hand side, it's just a numerical exercise. So we've got 54.6. I hit the natural log button, unary function. Almost exactly 4. Well, isn't that amazing? Okay, so now I've got a squaring that has to be undone. So clearly the square root of x squared must cancel out the squaring. Square root of 4. On the left-hand side, those cancel out, leaving just x. On the right-hand side, you get square root of 4. If you remember, there's two possible answers. We're going to pick the principal of those, which is 2. We're not going to throw weird stuff at you on the test. Yeah, so x equals 2 is in my list on that one. Most excellent. Okay. What else do we have? Oh, graphing. Okay, so a couple of graphs, and then we're all done. Graphing. Let's see. That looks like a graph of a line. I'm going to use the tricks we talked about where you can identify the y-intercept and the slope. I'm not actually going to calculate the slope. I'm just going to indicate the sign of it. Okay, so y-intercept. That's where it crosses the y-axis. So that's at positive 1. The slope looks like it's, if you're going left to right, it's a downhill. So it's a negative. Let's go through our list. Positive 1, that's cool. That first one is a possibility. Second one's a possibility. Third one's a possibility, but it can't be that one. Slope is negative, so can't be that one. Can't be that one. So we're left with that. So that must be our answer. Just to check it, the slope should be, the slope is negative 1/2. So this is rise over run. And so if you go 2 to the right, you should step down by 1. 1, 2, step down by 1. That looks like the right thing. So I think we're on track for that one. Ooh, that's a quadratic or a parabola. We have the same kind of trick that we can use for this. For some of these graphs that you'll need to know, you just have to know the shape of them. But for these two, the lines and the quadratics, the y-intercept is, again, at 1. And the curvature. Remember, the curvature is the a value. Curvature is, if it's a smiley face, it's positive, and that is a smiley face. It's happy because we're almost done with this practice exam. So smiley face, positive curvature a, positive a. So you look in our list, positive 1 intercept, can't be that, can't be that. Positive curvature of a, can't be that guy, so we're left with that one. Yeah, so that's how to do these kind of problems.